This integral question might seem very difficult until I show you how all of this becomes all of this. We start by identifying the trigonometric identities in the integral question. So first off, we will find out that sine 4x can be rewritten as is equal to 2 sine 2x cos 2x. And why is that? The reason is that sine a plus b can be rewritten as sine a cos b plus cos a sine b. This is a basic trigonometric identity. Okay? That means if we say sine 2x plus 2x, which is what 4x is, then we can say sine 2x cos 2x plus cos 2x sine 2x. All right, which will ultimately give us what we have at first. Okay, so we understand that sine 4x is the same thing as saying 2 sine 2x cos 2x. So we're going to replace sine 4x in the integral by this new trigonometric identity, and we're going to have 2 sine 2x cos 2x cos x all over cos 2x sine x dx. All right, and ultimately we can say that cos 2x is going to cancel out cos 2x, and now we are left with 2 sine 2x cos x all over sine x dx. All right, and ultimately sine 2x also can be written as 2 sine x cos x, and we will do the same thing and replace sine 2x in the equation with the new trigonometric identity. So we will have 2 into 2 sine x cos x cos x all over sine x dx, which ultimately gives us, of course, we know that since it's all multiplication, sine x can cancel out sine x, yeah, and we're left with 4 cos square x dx. As I said, all of what we had before is now equal to 4 cos square x dx, and by trigonometric identity again, we can say that 4 cos square x can be rewritten as 1 plus cos 2x all over 2 dx. Therefore 2 will divide 4, and we are left with in the integral of 2 into 1 plus cos 2x. I think at this point it's getting clear, yeah? And this will give us 2 plus 2 cos 2x dx. Let's put all of that in the brackets here. Okay. All right. And then we can separate that into 2 dx plus the integral of 2 cos 2x dx. The integral of 2 dx will give us 2x apparently, and the integral of 2 cos 2x is going to give us sine 2x, I believe that's just basic integration, plus c, since we do not have any boundaries. Okay? And therefore, we can say that the integral of sine 2x cos x all over cos 2x sine x is equal to 2x plus sine 2x plus c. All right? So in coming classes, I'm going to show you how to prove these trig identities. Thank you very much for coming to this class today. I hope you really enjoyed that. See ya. Bye.